geometries. So basically for today's question, we will only use these three simple geometries. Okay. So I think all of you know how to find the centroid for a rectangle. You guys just need to divide by 2 for the along the B, and also if you guys want to find the centroid of y value, you guys only need to divide by 2. And for triangle, it is a bit tricky, but you guys just need to know on which side the centroid should be. So the centroid should be closer to the 90-degree angle. Okay. So because the value depends heavily on which location of the centroid is, because the centroid is supposed to be closer to the 90-degree angle, because if you calculate from the acute angle here, it should be 1/3 time base. But if you calculate from the angle on the other side, it should be 2/3 times b. Same goes to along the y-axis. And for the circle, the how to find the centroid is basically based on the radius, either the value of centroid for y or x. Okay. So while waiting for your other friends, let's spend 10 minutes to solve the problem number 1. And then after 10 minutes, about 10 something or 10:13, we will discuss questions number 1. Okay. Okay, it's already 10 minutes, so we will start discussing questions number 1. Okay. Okay, so basically every simple geometry, they have their own respective centroid location, but when we have a combination of several shapes, the centroid change because it's a composite area. Okay, so in this case, we don't know the location of y bar of the composite area or the centroid axis. So that's what we are going to find. So to find the value of centroid y, we can use this formula. Okay, y equal to sum of area times with the value of respective centroid of each geometry, and then divided by sum of all areas. Okay, so before we start, kindly take note that you can see something like this. So what this means, and you can see the axis actually at the centroid here. So this is actually the questions telling us that if you want to find the value of centroid for each geometry, you guys have to measure it from the centroid from the centroid to the axis up here. Okay. So we have here, from the figure we can see that there are 3 simple geometries. So I will take this one, and this is the second, and this is the third. And each geometry we have its own centroid. So this is C1. So for example, this is C2, and this is C3. Okay. So as you can see from the formula here, we have to find a value of centroid for each geometry. Okay. So since the questions already give us clue from which to which that we have to calculate the value of y, so we just need to find the value. So from here to here, this is value of centroid y1, and from here to here, this is the value of y2, and from here to here, this is value of y3. Okay. Okay, so now we can find the value for each y. Okay, we start with y1. Okay, because the starting point is here, and the total length here is 15, so you guys just need to divide by 2, and you guys will get 7.5 millimeter mm. And this is to find y2. You guys have to find the distance from here until here. Okay, so that means the total length for segment 2 is 150. you guys divide by 2. This 150 divided by 2 is only from here to here. So you guys have to add the length of the segment 1. Okay, because we want the value reach the basis line here. Okay, you guys add with 15. Then you guys will get 90 mm. Now we find y3. So y3, so the r here is 50, and then you guys add with the length of the segment 2, 150, and then the length of segment 1, 15, and then you guys will get 215 mm. Okay. Okay. Since we already know the value of y, so we can directly use this formula to find the value of centroid y. Okay. Okay, so it says here sum of a product between y and also the area. Okay, we start with area number 1 first. So for area number 1, we know that the value of y1 is 7.5. And then we just have to multiply with the area of segment 1, which is 15 and 150. And then we plus with segment 2. So for the segment 2, y2 is 90. And then we multiply with area segment 2, which is 15 and 150. Then we plus with segment 3. So segment 3, the value of y3 is 215. And the area of a circle is pi r squared. So pi times with the r is 50 here, square. Okay, and then we settle for, and then we solve for the bottom part. So the bottom part is sum of all areas. So this is area for segment 1, this is area for segment 2, and this is area for segment 3. Okay. Okay. So if you guys solve the upper part, you guys get 1907981.051. The bottom part is 12, 12353.981. So you guys divide these two numbers, you guys will get 154 mm. So this is the answer. So are you guys clear with questions number 1? Is there any questions? I think question 1 is quite direct, so I hope it's clear with you guys. So you guys okay with questions number 1? So if you guys okay with questions number 1, I will proceed with questions number 2. So okay guys, so I proceed to questions number 2. Okay. Okay, so for questions number 2, it wants us to find both center of X and also Y of the shaded area. Actually, the given picture, actually this one, only this one. This is actually the given area, okay? So the given area also equal to the whole big triangle, and then you guys minus with small triangle here. So you guys also will get this uh, this final shape, okay? And for questions number 2 is quite different because questions number 2 give us the axis already, so we can know from where we want to find the value of center y and x for each shape. Okay, so you guys take 10 minutes, try to solve this question. It's easier if we use a table like this because we need to find uh, both x and y. So after 10 minutes, around 10:35, we will wait, so after 10 minutes, around 10:35, we will discuss questions number 2. Okay, so now we discuss question number 2. So okay, when we get a figure like this, so one of the ways to do this is we take the whole rectangle and then we minus the minor part of the shape so that it will be equal to the given figure. Okay, so in this case we will try this method, okay, where we will have two separate geometries. So this whole rectangle here is the first segment, and this whole thing here is the second segment. So when 1 minus 2, we will get the given figure. Okay. Okay, so the next thing is we have to find the centroid for each figure. Okay, as I mentioned previously, so for like example of the centroid of simple geometries here, so along the x and also y axis, to find the centroid of a rectangle, you guys just need to divide by 2. So same goes here. Okay. So you guys divide by 2, here you guys will get 6. Here you guys divide by 2, you guys will get 6. So that means so centroid for y is same, where 12 divided by 2 equals to 6. 12 divided by 2 equal to 6. So that means you already get the position. So the centroid for this big rectangle will be here at 0, 0. This is 0. Okay. So next is centroid for the triangle. As shown in the figure here, so the centroid should be closest to the 90 degree angle. So it should be somewhere around here. Okay. Okay, so to find value of x for the triangle here, 2/3 times with the it's okay. To recalculate this. Okay, I just need to show you guys this first. Okay, now we fill in the box here. So we have two segments, 1 and also 2. Okay, so the area of the segment 1 is 12 times 12. So you guys will get 144. And area for triangle 1/2 times with okay, for the triangle, the centroid is not at the location of the center here. So that means the calculation area of the triangle must be respective to the here, which means that minus whether it is positive or negative is important. Okay, for the rectangular here, the center is at the center, so that's why you can just directly 12 times 12 to get the total area. However, since the area of the center of the triangle is not at the exact 0 here, so you guys have to pay attention to the value, whether it is in the negative or positive region of the axis. Okay, so calculation area of the triangle is 1/2 times the length and width. So we take the width first. So the width is here -6. Okay, and the length. So the length is here, from here, which is +6. And this will equal to -18. Okay, so if you guys sum the total value of area here, you guys will get 126. Okay, so now we find the value centroid for each shape. So for segment 1, just now we already calculate this. We already calculate this, and this. So we know that the centroid is actually position 0, 0. Okay, so that means x is 0, y is 0. And for rectangle 2, for triangle, for the triangle segment 2, it will be 2/3 times with the total length of the x is -6. And that will equal to -4. And for y, 2/3 times with the total length, which is +6. This equal to 4. Okay, now the calculation centroid x times with a. So for segment 1, 0 times 144 plus 0. And for segment 2, -4 times with -18, guys get 72. And you guys sum this up, equal to 72. And now we proceed with the centroid y times with area. 0 times with 144 equal to 0. And for segment 2, 4 times with -18 equal to -72. So the sum of this would be -72. Okay, so now we already fill in all the values in the table, so we can directly calculate using the formula given here. Okay, for calculation of centroid x equal to so this value here is this value here. That means +72. and total area is here, and 1 to 6. So if you guys divide this up, you guys will get 0.571 inch. Y x and y for square is 0. Okay. Your friends ask why the x and y for square is 0 is because to calculate the value centroid of y, we basically use this formula where you guys have the total length and total width, so you guys divide by 2. Okay, so if you guys divide by 2, for example on this side b divided by 2, then the distance be here, the one that parallel to here is the centroid. So when we apply the same equation as given there, just now the equation says that b over 2. Okay, so this is b over 2. The total length is 12 and you guys divide by 2, that equal to 6. So the distance from here to here, like here to here, 6. If you guys can see, this is actually 6. So if you guys move 6 inch to the right, then you guys will get here the location is here 0. This is for x, and for the y also same. As you can see here, h divided by 2, the distance here will indicate the position of the y. Okay, so this is h over 2 equal to 12 over 2. You guys get 6. So that means the distance 6 here at the end here is the position. So if you guys intersect these two values, you guys will get the value here 0, 0. Okay. Actually, it is your friend asked. We just write the coordinate instead of the length. It is actually the length, but respective to the coordinate 0, 0. So as you can see here, the coordinate of the axis is 0, 0, and your length is 0, 0. So if you minus 0 is equal to 0. It's supposedly to be the length, but since the centroid of the square and also the coordinate of the axis they overlap, so if you minus the distance, it will be 0. Okay, just not to misunderstand, it's supposed to be length, but since they are overlap, so there is no distance to minus. Okay, so yes, for statement 1 we just write the value of the coordinate, because the coordinate and also the centroid overlap, so you cannot minus. Okay, I hope that's clear. Okay, so we already find the centroid of x. Now we find the centroid of y. Okay, so centroid of y is, the upper value here is here, negative 7, 2. Divided by total area is 1 to 6. So you guys will get negative 0.57 1 inch. So this is the final answer. Okay. Okay, do we have any questions here? Yes?
Miss,
Yes?
why is the 6 inch in negative?
Or which part?
For the segment 2.
7 2. Okay, then?
Why do we have negative 6?
Here, you mean, okay. You mean at the area?
Yeah, the area.
Yeah, the area here? Okay. So it's negative 6 because I write here B. Okay. As you can see, the total length, the position of the position from here to here is actually negative 6 because this is x and y axis. Okay, so this part is positive x and this part is negative x. The coordinate is actually, the length itself is negative 6, but for y here it's on the positive side of y axis, so it's positive 6. So that's why, based on this calculation, for the segment 2, 1 over 2, the base is negative 6, the height is positive 6. Okay, then equal to negative 18. Are we clear? Because this value has to be respective to the axis. So since it's on the negative side of the x-axis, so that's why it is negative 6. Are we clear? Because it's already given the axis there.
Okay, clear, Miss. Thank you.
But for rectangle, for square, we don't have to mind about the value, whether it's negative or not, is because the centroid of the square is actually overlap with the coordinate 0 0 at the center there. However, for the triangle, as you can see, the centroid is here. So if you guys want to find the centroid here, it has to be respective. It should be respective to the coordinate xy, which is 0 0. So that's why for the sign is important. Okay. Okay, so we have any other questions? Okay. Okay, so if there's no other question, okay, I give you guys 2 minutes to see this question number 2, in case you guys need time to read through before asking questions. So I give you guys 2 minutes. If you guys have any questions, you guys can just tell me. Okay, so we have questions. How do we know when we need to use the length or coordinates? It depends on the type of questions. Okay, usually when it wants you to use coordinate, it depends on type of questions. If you compare questions number 1 and questions number 2, in number 2 it gives you guys the axis. Okay, so usually when you guys have the axis, you guys have to uh, pay attention to the sign whether it's negative or positive. And for the length, usually it just gives you guys uh, indicator like this, indicator like this. So with this you guys find length. But if you ask me how to differentiate between the square and the rectangle when we have to use the length or the coordinate, when we need to use the length or the coordinate. Okay, it is actually length. Okay, the centroid of x and y is actually length from the centroid to the coordinate 0, 0. Okay, but since the centroid of the triangle is away from the 0, 0, so that's why its position is very important, whether it is negative 6 or positive 6, so that we know where is the position of the centroid of the triangle in the axis plane. However, for the rectangle, for the square here, since the value of the centroid of the square and also the coordinate, the center of the axis is overlap, so it's still you guys still to need to find the length. Is will be 0 minus 0, so that it's equal to 0. This is actually you guys still have to find the length. Actually, the rectangle actually also finding the length, but since it's 0 and the center of the plane also 0, so if you guys minus it, it's still 0. But in this case, to make it simple, I would say you guys need to do more practice and questions so that you guys can get the hang of it. It's basically generally the centroid of x and y we have to calculate the line. The coordinate when overlap. If I'm going to simplify the answer, most of all the time we find the length, but if it's overlap, it's coordinate. I hope that clears. So if we use length in this question, is it working? It's still working if you use length in these questions. For the square, it still work if you use length, because you know the centroid is 0, 0 based on the calculation here, and the plane center is 0, 0. So if you guys going to calculate the length, the distance between the center and also the centroid is equal to 0 minus 0. So the calculation of length still works. I hope that clears to you, Roger. Oh, okay. Okay, so if there is no other questions, we proceed with questions number 3. Okay. Questions number 3 is about the same with questions number 1. So you guys can take 10 minutes to solve this problem, and then after maybe around 11:13 we will discuss this question together. Okay, so I think we can discuss questions number 3 together. The questions for number 3 actually quite similar with questions number 1, but there is a different. There is one thing that the difference between them. Okay, so first, I'm going to redraw the I'm going to redraw the diagram first. Okay. Okay, so we now have the diagram. So because this is a composed area, so I divide this into two separate rectangle. So this would be the first one and this would be the second one. Okay, and this would be the C1 and here would be the C2. So if you guys, this is very important. So you guys have to pay attention to the clue given in the diagram. Okay. Okay, it's given that if you guys want to calculate to measure the centroid y of the diagram, you guys have to measure it from here. Here means the centroid. Example, the centroid is here. From here to the bottom. Okay. In questions number 1 just now, it gives us an indicator that we have to measure from the top, but here we have to measure it from the bottom to the bottom. Okay, so this is the one big difference thing between questions 1 and also questions 3. Okay, so that's why to find the value of centroid y, it should be from the center to the bottom. Okay, it should be between these two distance. So this is y2 and this is y1. Okay. Okay. Okay, so we already know from where to where we have to calculate the value of centroid y for each shape. So now we can have the value. So the value of centroid y for segment 1 is equal to, so as you can see, we have here 140 and then we have another small part here. So that means 240 plus, so 120, you guys have to divide by 2. And that will give you 300 mm. Okay, for y2 equal to, this one you can just divide by 2, is equal to 120 mm. Okay, so we already know the y here, so we can directly calculate the centroid y of the whole beam. Okay, so we arrange value for segment 1 first. So y1 is 300, and then the area of segment 1 is 600 times with 120, and then you guys plus with segment 2 centroid y2 is 120, and the area of segment 2 is 120 times 240. and the total area. So the upper part, you guys will get 250560000. Then the bottom part, you guys get 100800. And the final answer would be about 248.571 mm. So if you guys bundakan, you guys get 49 mm. Okay, so this is the final answer. Do you guys have any questions for questions number 3? I give you guys 2 minutes to read through the steps to see whether you guys have any questions or not. Okay, so if you guys are clear with questions number 3, I think we can proceed with questions number 4, if you guys okay. Okay, so if then, okay, so we proceed with questions number 4. Okay, so for questions number 4 is similar to questions number 1. Questions number 1. So pay attention from where to where you have to calculate the centroid y for each geometry. Okay, so this is from the centroid to the upper part of the shape. Okay, so you guys can spend 10 minutes to try questions number 4. Okay. Okay, so it's already 10 minutes. And your friend get the answer correct. The answer should be 79.6 something million mm. Okay, so I think we can start discussing on how to get the answer for questions number 4, because this is very similar to questions number 1. Okay, first we have to locate the segment first. So this is segment 1, this is segment 2, and this is segment 3, and this should be C1, C2 maybe somewhere here, and here is C3. Okay, so as you can see, based on the indicator here, so it wants us to calculate the value of centroid Y for each geometry from the top. Okay, so this is Y1, centroid Y1, and this is centroid Y2, and this is centroid Y3. Okay, so we find centroid for Y1 first. 15 divided by 2. Okay, that will equal to 7.5 mm. And Y2, 15, which is the length of the segment 1, and then we plus with the length of segment 2, 150. Guys have to divide by 2, and then you guys will get the Y2 to be 0.0 mm. And Y3, length of segment 1, 15, plus length of segment 2, 150, and then plus with segment 3 length divided by 2, and you guys would get 172.5 mm. Okay, so we already know the value of Y for each geometry, so now we can just directly calculate the value of the centroid y of the beam. Okay. Okay, so for segment 1, the centroid y1 is 7.5 and the area is 15 times 150, and then you guys plus with segment 2. So centroid for y2, centroid for segment 2 is 90 times with the area 150 times 15, and then plus with segment 3, the centroid is 172.5. So the area is 15 times with 100. Okay. Divide by the total sum of the area. So segment 1, 15 times 150. Segment 2, 150 times 15. Segment 3, 15 times 100. Guys, get the upper part to be for 7, 8, 1 to 5. And the bottom part, guys, we get 6,000. So that would equal to 79.68 mm, or equivalent to 79.7 mm. Okay, so this is the final answer. Okay, so this is what your friend got. This is how she got the answer. Okay, so do we have a question for question number 4? You guys can take 2 minutes to go through the steps and to see whether you guys have questions or not for questions number 4. Or if you guys don't have questions number 4, if you guys don't have any question for question number 4, question for other questions also be okay. Because we have about around 20 minutes, 17 minutes more. So we can spend the time to ask and answer questions. Okay, sure, Roger. Which questions you would like to ask? Oh, uh, hmm, Okay. Why the d why the dA is y2 minus y1? Why is the dA? Wait now. Why is the dA y2 minus y1? Oh, okay. Um,
Miss, you are mute. You are muted, Miss.
Okay, I'm sorry, I didn't realize that. Okay, just like your friend said, it's because of the lower and also upper limit. So you guys have to find the length between these 2 points. So that's why y2 minus y1. Okay. Same goes with other questions. Actually, this is actually the simplest form of the questions. Like we have this kind of questions, right? So usually we directly take the value. This is y, and this is x. Actually, this shape also has xy, and also it also has x y2 minus y1. But because the lower limit here, the y value is 0, so that would be y2 minus 0. So that's why we ignore the 0 value. We directly take the length, total length here, the y. So when you guys have a shape that is conquer two different area of the plane, that's why we have to consider y2 minus y1, because the y1 is no longer 0, so you cannot ignore that 0. The x1 and y1 actually has its own value that is not 0. So that's why when the calculation of dA, when you guys y2 minus y1 is basically you just want to find the length here. This is actually mm, this is actually to find area is length times width, right? So y2 minus y1 is actually the length, dx is actually the width. So to find the length of this rectangle, that's why you have to put the value y2 minus y1. If I'm going to put a value, like example, here is x2 and here is x negative 2. So the length here, the length would be 2 minus negative 2, because we get 4. So that means the total length here is 4. Are we clear? That way, who's asking this? It's Roger. Are we clear, Roger? It's actually normal shape also has upper and lower limit, but we ignore that 0 usually. Okay. So any other questions?
So this shows that it is upper line minus lower line for the equation. Miss, is it?
Yes.
Okay, thank you, Miss.
Okay. Um, any other questions? If you guys don't have any other questions, um, maybe we can end early today. Okay. So, okay. Thank you for today, you guys. May leave your next class. Thank you.
Okay, thank you, Miss.
Thank
Thank
you.
you.
Bye bye.